Hello! In this video, we are going to introduce you to ViDX, a system supporting visual diagnostics of assembly line performance in smart factories. We are going to demonstrate the system to you with a prototype web app we've built. The system supports both historical data analysis and real-time monitoring based on data collected during the operation of the machines and assembly lines. We will walk you through the individual components in the system. Let's start with the historical data analysis panel. The Historical Data Analysis panel consists of an extended Mary's graph visualizing the manufacturing process data, together with a calendar-based visualization and a timeline. They show the assembly line data at different temporal scales and at different levels of detail. On the left is a station map showing a schematic diagram of the assembly line. The histograms show the distribution of cycle time beside each workstation. At the center of the display is the extended Mary's graph. It uses a parallel layout of time axis. Each time axis corresponds to a workstation on the assembly line. The polyline shows when products finish their procedures on one station and move on to the next. The polyline here has two branches that are merged at station 170. This means that two parts of the product are assembled here. Before that, they are processed individually. The color of the line segments encode the cycle time on the stations. The color-coded circles show the occurrence of faults. The user can pan and zoom on the graph. Hide or show sub-processes by selecting on the station maps. They can also select production records by brushing. Immediately, we can see that the histogram on the left is updated, showing how the selected records compare to the rest of the dataset. The users can interactively identify the abnormal processes with two methods. In the first method, the user selects a range within 0 to 1. For example, here we select a range from 0 to 0.96. This range defines the corresponding quantiles of the cycle time on each station. A process is normal if its cycle times on all the stations are within the quantile ranges. In the second method, users can brush and select a few processes on the Mary's graph and label them as normal. The system will automatically infer the abnormal records using a label propagation algorithm. Next, we demonstrate some interesting patterns we find with the visualizations. On January 3rd, between 9 p.m. and 10 p.m., the entire assembly line stopped for approximately 1 hour. The 1 hour is the scheduled time for break. After that, the production line didn't come up to speed immediately and experienced a few glitches. It stopped completely and restarted for a few times before operating smoothly at midnight. On January 4th, around midnight, the processing of many products are postponed on the station 150. When they continue to be processed, the other products already on the line had to wait, and they no longer proceeded on the assembly line. It appeared that part of the assembly line was stopped for 5 to 10 minutes. Since the occurrence of faults are plotted on the time axis in the graph, it is relatively easy to assess the causes and effects of those faults. We can observe that when the fault shown here occurred on station 050, the affected products were no longer processed. After frequent occurrences of the fault, the entire assembly line would stop for 10 minutes or even longer. The frequent sequential occurrences of the fault and the pause of the entire assembly line point to potential causal relations. Predictive analysis becomes possible based on such observations to prevent potential losses. The calendar and the timeline give an overview about the throughput of the production line, and any particular time interval with low efficiency can be further investigated in the extended Mary's graph. The system also supports the tracking of real-time assembly line performance. It highlights the most critical information in real-time data to facilitate rapid response of operators and managers. On the left of the real-time monitoring panel is a 2D radial display, and on the right is a 3D visualization of the assembly line model. In the radial graph, the circle is divided into sectors, each corresponds to a station. Each of the concentric circles represents a product currently being processed on the assembly line. The light blue bars show the current positions of the products. For example, this product is shown on the station pointed to by the arrow. After finishing on this station, it proceeds to the next. The links of the bars represent the cycle time to process the products on the stations. The radial graph animates as real-time data comes in.